Hello everyone, welcome to Form 5 Addition Maths. This is the part 1 video for Chapter 5 Progressions. Before we start, if there is any corrections or additional notes, it will be posted in the description below. So in this chapter, we have two types of progressions we are going to learn. The first type is arithmetic progressions. So before we look at what is arithmetic progressions and what are progressions, there are a few terms that we need to clarify before we can look at the definition. So we start off by looking at these given numbers here. We have 3, 7, 11, and 15. So in Form 2, you already learned about sequence. So can you please tell me, is this a sequence? So we look at the numbers again, starting from the left. 3, 7. Okay, from 3 to 7, we add 4, right? We add 4 to 3, you get 7. 7 add 4, 7 plus 4, you get 11. 11 plus 4 is 15. If you can find a pattern for these given numbers here, then you can identify whether it is a sequence or not. So the pattern here is adding 4. Adding 4 to all the previous number. So 3, you add 4, you get 7. 7 add 4, you get 11, and so on. So this is a sequence. Now we look at the next example here. Is this a sequence? So we can find a pattern that 5 plus 3, you get 8. 8 plus 3, you get 11. 11 plus 3, you get 14, and so on. So the pattern here is adding 3 to all the previous number. Hence, this is considered as a sequence. So in this sequence, 3 is a constant, which is added to the previous number to get the next number. Okay, so 3 plus 5, you get 8. Yeah, is added to the previous number to get the next number, and 8 plus 3 to get the next number, to get the next number, and so on. So this 3 here, this value here is a constant, which has a specific name we call as common difference, and it's denoted by the symbol D. If we look back at the previous example, the D for this example, the first example here, will be the value 4. So the first thing we learn here is the meaning or the definition for common difference. We try a few more examples. Determine the common difference, D, the value of D, for the given sequence. Okay, so now we have 10, 18, 26, 34. Yeah, you are given a sequence and you need to find D. To find D, you take the second number minus or subtracted by the first number, the previous number. So 18 minus 10, you get 8. If you want to try to double check your answers, you take 26 minus 18, you get 8 as well. 34 minus 26, you get 8 as well. Now, because D here is a constant throughout the whole sequence. Try again. Now we have 23, 19, 15. Notice that the numbers is getting smaller and smaller. Okay, so to find D, we take the number here or second term. 19, we minus the first term, first number. So 19 minus 23, you get negative 4. Hence, D, the common difference, has a value of negative 4. So take note here, D can have a negative value if the numbers in the sequence is getting smaller and smaller. Okay, we have another concept that you need to learn before we can look at the definition of arithmetic progression, the concept of terms. Okay, so in this given sequence here, the 10 is the first term of this sequence. So 12 is the second term, 14 is the third term, and so on. Okay, so actually you already learned the meaning of terms in Form 2 as well, in chapter patterns and sequence. The first term here, we use T1 to denote the first term. So the second term we have T2, T3, the fourth term will be T4, the fifth term will be T5, and so on. So for any term after the term 16 here, we can use n term to denote the number. So n term will be denoted by this symbol here, which is Tn, okay, to represent the nth term. So after you understand the common difference and the meaning of terms here, okay, we look at this given sequence. So we want to relate this now with common difference. So in order to find the common difference D, we can find the values, we can determine the values of D by taking the second term minus the first term, which is T2 minus T1. Or we can also take the third term minus the second term, T3 minus T2. The values will be the same as this. Or you can use the fourth term minus the third term, or here Tn minus Tn minus 1. All these will get the same values for D. Okay, in order to find the common difference, we take any terms in the sequence minus the previous term. So now we are going to look at the definitions of arithmetic progressions. So arithmetic progression is a sequence of numbers such that each term is obtained, you get the next term by adding a constant to the term before it. For example, we try to identify whether this is an arithmetic progression. So each term is obtained by adding a constant. Okay, so 8 is obtained by adding 3 to 5. 11 is obtained by adding 3 to 8. 14 is obtained by adding 3 to 11. So we are adding a constant here, which is 3. We add 3 to the term before it. Hence, this is an arithmetic progression because the next term here is obtained by adding a constant here, which is 3, to the term before it, which is for 8, which is 5. Hence, this type of sequence here, we call this as an arithmetic progression. In other words, arithmetic progression is a sequence that has a common difference. You see the common difference here is 3. In short, conclusion, if you can find a common difference of a given sequence, then it is an arithmetic progression. Example 1. Determine whether each of the following sequence is an arithmetic progression. Okay, give your justification, means give your reasons. First, this is a given sequence here, 9, 5, 1 minus -3. And now we want to determine whether this given sequence is an arithmetic progression or not. Hence, we try to find the common difference. We take 5 minus 9. The second term minus the first term. 5 minus 9 to get the first difference, which is D1. Okay, 5 minus 9, you get -4. Then we try 1 minus 5. You get -4 as well. -3 minus 1. You get -4 as well. Hence, the difference here is -4. -4 is the same, hence they are common difference. And this sequence is an arithmetic progression because D1 equals to D2 equals to D3. It has a common difference. We are given this 3/2, 5/4. So we try to find the first difference here by taking 3/2 minus 3. You get -3/2. We try to find the second difference here by taking the third term minus the second term. You key in the calculator, you get -1/4. Are they the same? No, they are different. Hence, there is no common difference. D1 is not equals to D2. This is not an arithmetic progression. Try the next one. You have this. Now it's in the form of surd. First, we find the first difference here, which is 10 surd 5 minus 3 surd 5. You get 7 surd 5. So for the second difference here, you take 17 surd 5 minus 10 surd 5. The third term minus the second term, you get 7 surd 5, which is the same. Hence, since D1 is equals to D2, this sequence has a common difference, which is 7 surd 5. The D equals to 7 surd 5. This sequence is an arithmetic progression. Now we look at example 2. Complete the network diagram. Given that the relationship of each of the following network is a consecutive term in an arithmetic progression. This is similar to the exercise in your textbook. We try to analyze the network here. You can see that this circle, and this circle is linked by this line. This is linked by this line, and here we have another line here. Meaning that the numbers along the line is a sequence. Yeah, and it is an arithmetic progression. So here we have an arithmetic progression. Here we have another sequence of arithmetic progression, and here we have the third one. We need to have at least 2 terms of a given sequence. Okay, so this sequence here, we only have 1 value, we cannot find it. And this sequence from 6 to 36, we have 2 values, hence we can use this to help us to find the values in the middle. There are a few ways we can do this. I'm going to only show you one here. So remember, since this is an arithmetic progression, from 6, if you want to get the next value, we need to add the common difference. From here, you want to find the next value, we need to add another common difference here. Meaning that 6 plus D, you get 36. So 6 plus 2D, D plus D is 2D, you get 36. So in order to find the difference here, common difference here, 2D equals to 36 minus 6 to find this value in between. Yeah, so 2D equals to 36 minus 6, which is 36 minus 6 divided by 2, and you get 15. Meaning that 6 plus 15, you get this number, which is 21. Second term is 21. So we double check. 21 plus 15, you get 36? Yes. Now since for this sequence here, we have the first value and the third value here, we can find this using the same method as well. Okay, so now negative 3 plus d, you get the second term. The second term plus d, you get the third term. So 2d here equals to 21 minus negative 3. So to find d, we move the 2 here, you get this, you calculate this, you get 12. So negative 3 plus 12, you get 9. Hence the second terms here has a value of 9. So since you know 9 here and 6 here, I think you can find the last value. So the answer is 3. So after all these examples, I think you already have a basic understanding of the definition of arithmetic progression. So we look at other examples here. So now, let's say you are given an arithmetic progression. Can you find the 32nd term for the arithmetic progression? Do you know what is the value of the 32nd term? How are you going to find it? There is another smarter way we can use in order to find the 32nd term, which is by using the formula. So before we look at the formula, we derive the formula to find the nth term. Now the nth term can be any terms that we want. So to derive the formula, okay, we write down the sequence here. T1 first term, second term, third term. If we let T1 equals to A, okay, so we always use A to represent the first term. Then the second term will be A plus D. Okay, the first term is, if this is A plus D, you get the second term. D is a common difference. Then to get the third term equals to the second term plus D, right? So third term equals to second term plus D, plus the common difference. Okay, and second term, remember second term here, T2 equals to A plus D. So T2 here, we replace this with A plus D. You get A plus D plus D. We simplify this, you get A plus D here to 2D. If you want to find the fourth term equals to the third term, T3 plus D. And T3 here equals to A plus 2D. So we replace this with A plus 2D and A plus 2D plus D. Here we simplify this, we get A plus 3D. So now if you rewrite all of this, you can find the pattern of finding the nth term. Okay, so the nth term is equals to what? Yeah, you can see that A is OA here and D here. And how about this value? Okay, the value here, the coefficient of D is always 1 less than the terms that we are looking for. Okay, 3 is less than 1 less than 4. 2 is 1 less than 3. So if this is n, this will becomes n minus 1. So this is the formula. You can use this formula to find the values of any terms. So with A equals to first term, D is the common difference. So we look at the examples of how to use this formula. Example number 1. Find the 10th term for the arithmetic progression. Okay, so A is negative 4, the first term. Then we need to find the common difference, D. We take the second term, negative 1 minus negative 4. Okay, negative 1 minus negative 4. You get 3. So since we already have the values of A and D, we can use the formula here. A negative 4 here, this is negative 4. D will be 3. And since we are looking for the 10th term, this will be T10. Okay, so T10 equals to negative 4 plus, so N here is 10. Okay, 10 minus 1. And D here is D here, which is 3. The common difference is 3. Calculate this, we get the answer. The T10 equals to 23. Example 2. So first we find the values of A. A is the first term, negative 3. Then we find the common difference by taking 2 minus negative 3. Here D equals to 2 minus negative 3. You get 5. Fill the values into the formula. 32. So T32 equals to A is negative 3. N is 32. D is 5. Fill in the values, calculate this, you get 152. Example 3. Given an arithmetic progression with the first term is 10 The common difference is -6. So this time you are not given the arithmetic progression, but you are given A is 10, you are given D is -6. So Tn is 38. Now we need to find the value of n instead. Okay, so of course we use the formula here. Tn is the nth term. Tn is the nth term, so Tn is this -38. A will be 10, n is the values that we are looking for, D will be -6. We fill in the values here, you get this. Okay, so because Tn is -38, okay, we fill in the values, we solve this, we find n. We find this, and plus 1, you get n equals to 9. Meaning that the ninth term has a value of -38. Example 4, find the seventh term for the arithmetic progression. Okay, so the arithmetic progression does not have to be values. It can be in the form of algebra expressions here. So the steps are the same. A equals to 2x plus y. D is the common difference. We take the second term minus the first term. Okay, 3x plus 2y, the second term, minus 2x plus y, the first term. So 2x minus 3x minus 2x, you get x. 2y minus y, you get y. So the common difference is x plus y. Fill in the values to the formula. Seventh term means T7, 7 here. Okay, so T7, A is 2x plus y, 7 minus 1, D is x plus y. Simplify this, you get T7 equals to 8x plus 7y. Example 5, given this is are 3 consecutive terms in an arithmetic progression, find the value of m. So these 3 terms can be related by using the common difference. Okay, so what I mean is we find the common difference for this. So the first difference is 4m, the second term, minus the first term, 4m minus 2m minus 1, which is 2m plus 1. Okay, so 4m minus 2m is 2m. Negative here, plus becomes positive, plus 1. So the first difference is 2m plus 1. The second difference here is the third term minus the second term, 13 minus 4m, minus 4m. So since this is an arithmetic progression, meaning that this sequence of number has a common difference. They have the same difference. Means D1 is equals to D2. Means 2m plus 1 equals to 13 minus 4m. Okay, then from here we can solve it. We find the values of m, we move everything here. 6m equals to 12, m equals to 2. The third term and the fifth term in a given arithmetic progression is -10 and -20. Find the first term means find the value of a. The common difference means find the value of d. And 12th term means T12. So in order to find this, first we write down what information we have. Okay, the third term is -10, T3 equals -10. The fifth term is -20 given here. We need to first convert this using the formula. So with the formula, T3 equals to A plus 3 minus 1D. Okay, so I can rewrite this as A plus 3 minus 1 to get 2, D equals to this. Okay, this comes from here using the formula. Same applies to T5. T5 here, T5 equals to A plus 5 minus 1, D, which is equals to -20. So you see now we have one equation and two equation with two variables. Hence, we can label this as equation 1, equation 2, and solve this using solving simultaneous linear equation. So there are two methods you have used, elimination or substitution. So in this case, since A have the same coefficient, we use elimination. Okay, 4D is bigger than 2D, so I take equation 2 minus equation 1. Okay, so equation 2 minus 1, 4D minus 2A minus A, 0. 4D minus 2D, you get 2D. -20 minus -10. So now we can find the values of D. -10, D equals to -5. After we find the values of D, we substitute D into any equations given. Equation 1 or equation 2, you get the same answer. Okay, so here I substitute into equation 1 here, so the D here becomes -5. Okay, a plus 2 times negative 5 equals to negative 10. Solve this, a equals to 0. Means the first term is 0. Then, since we already find the first term and the common difference, we can find the 12th term by using this formula. T12 equals to a is 0, n is 12, d is negative 5. Hence, we substitute the values, we find the answer. This is the end of part 1 video. See you then.